Hey guys, this is the Vincent Code, and in this video, we will talk about linked list. So first of all, let's define linked list. Linked list is a sequence of links which contains items. Each link contains a connection to another link. Linked list is the second most used data structure after array. So to understand better what is a linked list, so let's look at this representation here. So this is a representation of a simple linked list. So from the description above, linked list is a sequence of link. So the links in linked list is called node. So these blue figures here, these are the nodes. So each node has two fields, the data and the next. So the data, this can be an integer or character, so this holds the actual value of your list. And the next here is a pointer that will point to the address of the next node. So here we have the head, so head is the first node, so the first node is called the head. And then here the last node, the next of the last node, or the pointer of the last node, this will point to null. So here, for example, we have a list of 1, 2, and 3. So the first node here has a value of 1, second node has a value of 2, and the third node has a value of 3. So the data of the first node is 1, the data of the second node is 2, and the data of third node is 3. So the values 1, 2, and 3 will be stored to data. So let's say that the data here is an integer. So our next is a pointer that will point to the next node. So this pointer here, we will store the address of this node here in this pointer. So our value 1, so in this first node, the actual value will be 1, but the memory that we will store in this node is the memory of our second node. And then here in our second node, so the data will be 2, and the memory will be the memory of this third node. So when we access the first node, so we can locate the second node by using this pointer next the memory of the second node. And here in our last node, so the data will be 3, but the pointer here next will point to null, indicating that this is the last node, because it will point to null, it will point to nothing. So there are three types of linked list: the simple linked list, doubly linked list, and circular linked list. So simple linked list, so item navigation is forward only. Doubly linked list, items can be navigated forward and backward. And in circular, the last item contains the link of the first element as next, and the first element has a link to the last element as previous. So let's look at its structure or the representation. So this is the representation given above. So this is the representation of a simple linked list. So item navigation is forward only, so you can navigate from first node to last node, so one direction only, from left to right, and you cannot navigate from right to left. So this is the simple linked list. You can only navigate from left to right, from your first node to the last node. So doubly linked list, items can be navigated forward and backward. So unlike simple linked list, so a doubly linked list can be navigated forward and backward. So it means you can navigate the list from left to right and right to left. So this is the representation So in simple linked list we have only data and next. So here in doubly linked list, so we added another field for our node and we called it previous. So data here is data. It could be integer or character. While next and previous here, these are pointers. So see, next and previous, they are pointers that will point to the next node. So here next will be pointing to the next node, and previous will point to the previous node. So by that, it is possible for the doubly linked list to navigate from um, forward and backward, because we store the address of our previous value in each node. So here in this, so let's say this data here is 1, here 2, here 3. So the next the pointer next of our first node will be pointing to here, to our second node, and in our second node the pointer next will point to our third node, and here in our third node next will point to null, but the pointer previous of our third node will be pointing to the second node. So the memory address of the second node will be stored here in previous of our third node. So by that we can navigate from the third node to the first node. So that is the difference between doubly linked list and simple linked list. Simple linked list item navigation is forward only, and doubly linked list items can be navigated forward and backward. So in our doubly linked list we have 3 fields in our node, and in simple linked list we have only 2, data and next. Here we added previous. So the next type of linked list is a circular linked list. So the last item contains the first element as next, the first element as a link to the last element as previous. So from the word circular, we can see here that navigation is circular. So here we have only 2 fields, the data and our next. So same with simple linked list and doubly linked list. Data is the whole is the actual value, or holds the actual value, and our next here is a pointer that points to the address of the next node. So the only difference here between simple linked list and circular linked list is here. So in simple linked list, the last node will point to null, but here the last node will point back to the first node. So in our first node, so here the pointer here will point to the second node, and in our second node the pointer will point to the third node, and on the third node the pointer will point to the first node. So that's why it's called circular, because as you can see, the direction of the list is circular. So that's it for the types of linked list. So now let's create a simple linked list to understand how it works. So this is the code implementation of a simple linked list. So using C as a programming language. So first is the include stdio.h and include stdlib.h. So first thing is to create the node. So since this is a simple linked list, so we have only here 2 fields. So int value for the value, the actual value. So we will be using integer. We will store numbers here. So this will hold the actual value, And then we have here the pointer. So struct node next. So next is a pointer of our node. And then next is we will create a function that will print all the values in our list. So void, I named this print list, and then I put a parameter pointer because in our main function we will pass a pointer value on this print list. So while p is not equal to null, so from the representation I gave above, we've seen that the last node will point to null. So here, while p is not equal to null, so while p is not equal to null, so we will print the value. So while we haven't reached the last element, so we will print the value, and then p is equals p next. So this code here, it's like incrementing your while loop to print all the elements or the values of your list. So here in our main function, so we have first we declare pointer again for our values. So in this example, we only have 3 values for our list. So first is the head. So struct node head. So make sure that you have asterisk because this is a pointer. And then 1 is equal to 1 equals null, 2 equals null, 3 equals null. So next, after we declare here so 1, so that's why we include stdlib here because we will be using malloc. So 1 equals malloc size of struct node. So this code here just creates 1 as a node because we allocate 1 memory size of our struct node. So our 1 here can now hold a value and a pointer. So same with 2 and 3. So after we allocated memory for our pointer 1, 2, and 3, so now we will assign values for 1, 2, and 3. So we will call the first for the 1, so we will call the value field of 1, and we assign it to 1. So this pointer here has a value now of 1, and same with 2 and 3. So the value of 1, 2, and 3 now are 1, 2, and 3 respectively. So next is, so we have now the values for our 1, 2, and 3. So now let's go to other pointers. So this code here, this will link our list. So this will link our list. So first is we call the pointer of our 1. So next is our pointer. So 1 next is equal to 2. So that means that 1 has a value of 1 here, has a value of 1, number 1, with a pointer, of but its pointer holds the memory of 2. So our first node now has a value of 1 and the pointer that points to our node 2. So because 2 is our second node. Now let's do the same with our second node. So let's call 2 and then let's call its pointer, and then let's store 3 to pointer of our node 2. And then the last node, so 3, so we will assign null to the pointer of our last node. So this code here basically assigns the values in the pointers, and so a pointer holds memory address, So on our first node, we have a value of 1 and a memory address of 2, because here 1 next is equal to equals 2. So next, so 2, the memory address of node 2 is now here on our 1 next to the next of our first node. And then here the second node, so the pointer of the second node points to the third node. So that is the basic implementation of the linked list. So here we assign 1 to the head because 1 is our first node, so we will call it head. So let's assign it to head, and then here head, we will pass this to our function print list and then return 0. So let's look at here. Let's run the code I shown you. So when we run this code, so basically this will just display 1, 2, and 3. So 1, 2, and 3. So that's it for the introduction of our linked list. Simple linked list. So I hope you understand my explanation of linked list, and if you like my content, please consider subscribing to my channel. Like, comment, share, and subscribe for more programming tutorials. And if you have topic suggestions to tackle, so just comment on the comment section. In our next video, we will be discussing the basic operations of the linked list. So that's it for this video. Like, comment, share, and subscribe.